And welcome everyone to the presentation. When I first joined EasyPower and I learned what arc flash is, it amazed me that people would delay conducting an assessment and taking on the task of making sure their workforce was safe from the hazard involved. And today, there's still a fair number of people that come to us looking for information without having any previous knowledge of the hazard. And so we developed this presentation that we call the 10 recommended steps to an effective assessment. Step one is to acknowledge the hazard. Our common misconception among seasoned, especially longtime electrical workers, is I've worked with 480 volts for 30 years. I don't think we need to worry about arc flash. It's never been a problem for me. The fact is arcing faults can release dangerous levels of radiant energy, plasma, metal, and arc blast pressure waves are capable of causing severe burns and injuries. Industry pundits estimate there's less than 35% of the US companies compliant to NFPA 70E today. And as Randy mentioned, we do a monthly workshop, and an average of 45% of the attendees there report that they're just getting started on the journey. So I applaud the intent, and hopefully we'll give some guidance on how to kind of tackle the task. OSHA 1910 subpart S mandates that any employee who might come in contact with electrical hazards must receive electrical safety training. And though not specifically calling for NFPA 70E training, it's considered the industry standard for worker safety and compliance. It struck me that Ben Franklin may have been more of a pioneer than we recognize or have understood with his work in the lightning rod. He discovered that lightning in the air is electricity, and when air is a conductor, electricity can be dangerous. He developed a lightning rod to redirect the electrical energy to ground safely. And while this protected the house, it's ironic, and I think Justin mentioned that probably the latest innovation in electrical safety and arc flash avoidance is a system called quenching, which does the same thing. It redirects the electrical energy to ground, protecting not only individuals, but the rest of the equipment. So it seems like we're coming full circle on this discovery. Since the days of Edison and Tesla, high energy explosive accidents occurred in electrical systems, damaging equipment and injuring workers. And at the time, not the exact feature and the cause was known. Some labeled them acts of God. In the mid-50s, the Navy made the observation that some of these events occurred when workers were moving things around or involved with the activity of the equipment itself. And as many times as I've made this presentation or done a workshop, I never had to really define what arc flash is. And I took it on as part of this presentation because I think it's not well understood by the layman. An arc flash event is self-sustaining high current passing through a plasma arc, which is ionized air that require the large amounts of radiated energy and produces large amounts of radiated energy. The problem is, and the real issue, is that this path is not confined to the system hardware. And so its event or its avoidance was not part of the original design. So Ralph Lee's model, released in the 1980s, estimates the amount of energy released over time when one of these events occurs and correlates the heat damage to unprotected skin. Now, as an example of what this means, and this is getting a little bit into the weeds, but this is a picture of what's called a bolted fault test setup. And it's the way pieces of equipment are tested. Literally, the outputs are tied together with this piece of copper. It looks like it's about 3 inches wide and a 1/4 inch thick. And the equipment's supposed to not only survive, but interrupt the current flow to protect whatever's loaded into the equipment beside it. Now, when it comes time to do an arc flash test, this is what the fixture looks like. And this little 12 gauge wire that's strung from the different contacts vaporizes when the current is turned on and creates the plasma ball. And as long as that plasma can touch the electrified buswork, the arc itself will propagate from wherever it started to a full-blown three-phase fault. It literally takes 30 milliseconds or less, even if you just try to fault one bus. So the body of knowledge of arc flash features and characteristics is growing. So the problem is not thinking that it doesn't exist because you haven't seen it. It may be that you just were lucky during that time, and all you have to do is be unlucky one time to have a very bad day. So acknowledging the hazard is the first step. Then you need to understand the risks and responsibility of you as an employer or as a company CEO, because an effective electrical safety program that includes arc flash risk assessment is not only the right thing to do, it can also mitigate the millions of dollars in losses that can arise from a single incident. These incur medical treatment for victims, legal defense fees, OSHA fines, lost worker productivity, and in some cases, increase in insurance premium. Just as an example of kind of the trade-off involved, electrical hazards are a very low frequency event. They only end up occupying 3.6% of the occupational fatalities compared to the rest of the industry. On the other hand, it's a high consequence event. So it can be the seventh leading cause of occupational fatality, but the second most costly workers' claim. And this is reported by at least one utility company. I had a recent conversation with a purchasing manager at a local company, and I asked her how your facility, whether it was compliant with NFPA 70A, and if they had arc flash labels on the equipment. Her response surprised me. She thought that that was the reason that they had electrical contractors do all the work. The reason this is kind of interesting is that I had a complaint or a question come in from a facility engineer at a automotive assembly plant. And he was asking me about labels, and the answer to his question, I think, covered the situation with the purchasing manager, and that is in NFPA 70E Article 130.5H, the standard states the owner of the electrical equipment shall be responsible for the documentation, installation, and maintenance of the marked label. So even if we have a contractor doing the work, they don't own the equipment. They may contract to do some kind of labeling, but ultimately it's the owner of the equipment that has the responsibility for making sure that that's done. And so that's the reason often equipment installation contracts require that equipment be labeled per NFPA 70E, not just the National Electrical Code, before title is accepted on new equipment. So step 3 is define your path forward. Once you understand what the hazard is and you have a goal that you want to meet a certain level of safety compliance, you would determine the gap between your current status of safety, electrical safety, and your goal, and then develop an action plan and timeline. A goal without a timeline is just a wish. And so it's important to lay this all out as far as your expectations over time. Now, the timeline should include up-to-date electrical drawings, short circuit electrical duty studies, protective device coordination studies, and then an arc flash risk assessment. It's virtually impossible, in my opinion, to have any semblance or resemblance to a electrical safety program if you don't have an accurate one-line diagram. And unfortunately, or more accurately, the data collection on an existing plant can be very time consuming. And so traditionally we see easily 50% of the total person hours required to do a study involves collecting data and then modeling. Now this can be outsourced, but it's actually a good training opportunity for your maintenance team and employees if they haven't been exposed to arc flash to understand the components of what makes arc flash a hazard. And so you can use CAD tools to create the database, but you need to utilize available resources to do this efficiently. For instance, we have a free arc flash safety book that you're welcome to download as a PDF copy that covers soup to nuts, all the way from doing data collection up to doing labeling, and it'll give you an idea of what to expect even if you contract out the service. In addition, as Randy mentioned, we do a monthly arc flash workshop that's free and online, and easily half the audience every month is beginners and just looking for some direction on how to get started. The data that's required is loaded in the software. This is a screenshot of what's called the utility data dialog box. And probably as much as anything, this is an important element that you need to retrieve from the utility company because the available short circuit current is the starting place for the fault if it occurs in your plant. So the available short circuit current, three-phase and single-phase impedance to ground, and the impedance of the three-phase fault are required. And beyond that, the next most important element in the data collection in the one-line diagram is the transformer, substation transformer. And for that, virtually every bit of information is on the nameplate of the transformer itself. So this includes the kVA rating or MVA rating, the impedance, the configuration, whether this is delta Y or delta delta or Y delta, and then the temp range. Cable data is surprisingly important because it's going to influence the amount of inductive kick when an arc forms, and at the same time it limits the current based upon the length and the resistance of the cable. And then obviously motors, heaters, and lighting panels, which are the system elements and can be included in the one line. One of the things that I harp on during the workshop is how important the time of the arc to extinguish is, and the elements that control that are referred to as protective devices, which include breakers, fuses, and relays. So the details as far as the manufacturer's data sheet, which are all included in the software, have to be included in the data collection process. This includes fuses and relays and the set points and all the manufacturer's designation for utilizing that as a safety device. Now, once that's completed, the first order of events is called the short circuit study. And that's necessary because it will determine the worst case fault current at every bus in the system. Now, most software packages will be able to accomplish this without too much effort once the data has been entered and is accurate. So what it produces is a three-phase bolted fault, a line to ground fault again at every bus in the system, and then the line-to-line faults, including all current sources during the fault. Probably the most dangerous facilities are the ones that have high motor contribution, because large motors can end up acting like a generator during a faulting event. And then in addition to the maximum current produced, we need to create or evaluate the equipment duty, which Justin referred to as one of the requirements of a normal working system, and that is the equipment's rated to withstand the worst case fault. And that's dependent upon the maintenance and the condition of the equipment to ensure that it's going to work if it's needed. And then protective device coordination is usually included in this step, and involves a selective coordination to improve system reliability, which means you minimize the unnecessary system shutdown on loss of remote load. It's not required by the National Electrical Code except for emergency critical loads, but it's good to check to make sure what the impact is on arc flash hazards, and it will determine which response time needs to be adjusted for mitigating arc flash. And then based upon that, following the IEEE 1584 guidance, you can complete an arc flash assessment. Again, it's a heavy calculation intensive step, and most of the software will handle it, but it requires knowledge of how to apply the software conditions. You need to consider the working distance for removing the cover. There was a good question in Justin's presentation. The equipment, the label that goes on the cover or the door of the equipment has a working distance usually determined by the IEEE standards, and usually for 480 it's 18 inches, and it really just gives some advice to somebody in the area who will remove the cover. Many people consider the label to reflect instant energy once you get inside the panel, and it does not. That information, frankly, goes on to a work permit, and so never the twain shall meet. But during the arc flash risk assessment, the tools can consider different working distances based upon whether or not you're going to have to do hot work or just observe it like you would on a thermal imaging. But in addition to labeling the equipment, you'd also determine the protective measures and the PPE requirements. And then once you've got these results, you need to really analyze and take stock of your situation. You need to really understand what equipment needs to be worked on, what can be processed, de-energized, and determine the maximum risk that you want to take as an organization, including the need to expose people to instant energy, the arc flash boundaries that will exist that could affect other workers in the area, and then the limited and restricted shock boundaries, which are going to be present once that cover is removed. And all this is per NFPA 70E guidelines. So the results end up being you have a well-documented one-line diagram. You have the ability to calculate instant energy, both for normal events and for the need to do mitigation. And at that point, you want to prioritize hazard elimination. Justin referred to this as well. It's called the hierarchy of risk control methodology to minimize the influence of human error. When in the early days of NFPA 70E, including arc flash, the whole focus was putting on more PPE to keep people from getting hurt while they're working on the equipment. These days, it's recognized that there can be an order of hazard elimination if we follow this hierarchy method. And the first step is to eliminate the hazard, which primarily is de-energization as a first step. And then substitute with the equipment with safer equipment. There's technology now for trip units that can be adjusted or set to operate quicker or faster during a work in process situation, so that personnel are exposed to a lower hazard, including this technology. And then, as Justin explained, engineering controls for remote operation are a good solution for mitigating exposure. And more, the industry is becoming aware that these first 3 or 4 steps or methods are reducing the hazard or trying to mitigate the exposure. But in fact, it doesn't negate or reduce the number of accidents as they happen. What does reduce the number of accidents is better training, better controls and documentation, and then understanding of what the ultimate goal is as far as the safety and adherence to the procedures. And frankly, PPE training is the last line of defense. Lockout tagout is required to ensure the equipment's been de-energized, and this is required training for anybody in electrical energy employment to be re-upped every 3 years or sooner if the equipment is changed. Then step 6 is to consider PPE as the last line of defense. You want to ensure the proper selection and assigned risk of the task involved. Train qualified workers to be able to properly wear and make sure their body parts are covered as required. And then it's important for the provider or the user to review the care and cleaning appropriate to the manufacturer's instructions. Step 7 is energized work permits. I pause because it's difficult for people to understand that this is not something that should be considered a burden. It's required by NFPA 70E for work over 50 volts, and it should list the work to be done, the safety measures involved, and procedures to be followed, and primarily make sure that management and technicians sign it, the work permit, to include or verify that we have management support for workers to be put in an elevated hazardous situation. There are examples in NFPA 70E, and software like EasyPower can produce these automatically utilizing the results of the safety assessment. And this would be where any enhanced mitigation steps like quicker tripping units would be invoked for the work in process. An arc flash risk assessment, as well as some of these other steps, is just part of an overall safety program, and it's more than just the study. And so it needs to be documented as a complete electrical safety reference for the organization, and policies should be encouraged such that management is as serious about the application as the qualified workers. Using NFPA 70E as a guide will help satisfy the OSHA requirements. It's not legal, or it's not a legal document. So if you have a better way of protecting your workers and educating them, then by all means do it, but make sure you document what you've done and how that is enforced. And then the system should be reviewed periodically and be able to accommodate changes both in the standards and in the facility equipment. And then you should have an audit system that verifies the procedures are being followed. Step 9 is training. It should be required for our qualified workers and operators. This should include company work procedures and safety policies, reviewing electrical safe work practices, allowing for auditing and changes in the equipment and the procedures. Now, data has shown that studies, mitigation, and labels aim to reduce the effects of accidental events. But it's the training, refining procedures, and safety focus that reduce the frequency of the accidents. So a mature safety program is one that has qualified worker buy-in. Suggested improvements come from the bottom up, and they're not necessarily originating from the top down, and it's due to having regular safety reviews and audit systems with built-in positive feedback, not threats or penalty or demerits. And then step 10 is make sure you have equipment maintenance that's included or referred to now by NFPA 70B, which has been recently released as a standard. It used to be recommended practices. Now it's mandatory. And the purpose is to provide for electrical safeguard to persons and property and process from risks associated with equipment failure or malfunction. And what it gives us are descriptions of different levels or conditions that can be accepted and evaluated during the data collection assessment. And here's 3 reference points that are general in nature, but could be modified for particular applications. But it goes further where you have equipment that is doubtful as far as it's going to be productive use and can be counted on for interrupting a fault. And in other words, it's in bad shape and poses a risk and should be immediately maintained or removed from service. So those are the 10 steps that we consider to be necessary for an effective arc flash risk assessment. The bottom line is, based upon your gaps, this are my recommendations. Based upon your gap situation, find a reliable, trusted source that has the capable and credible experience in arc flash technology, and balance your goals and resources to commit to a realistic plan, and make sure you include training as the bottom line. Thank you.
Okay, thank you very much, Jim. Excellent presentation. We have a number of questions. The first one being, is an arc flash study required by the National Electrical Code? Secondly, is there a rule of thumb to determine the cost of an arc flash study?
The first question is, National Electrical Code does not require an arc flash study. It does require arc flash labeling, but it's generic in nature, and it refers, that being the National Electrical Code, it refers to NFPA 70E for details of an assessment. So indirectly, it refers to it, it doesn't require it. Now, with that said, and just to kind of jump ahead, NFPA 70E is not a legal document, but arc flash assessment can be part of the original design requirements, and as such may be covered by local code restrictions. So the guidance there is to utilize NFPA 70E for the assessment, which gives you a double whammy as far as legal jurisdiction. And what was the second question? That was a tougher one.
How much does it cost? What's the rule of thumb for determining how much an arc flash study should cost?
Well, it's an hourly rate. And so if you're going to contract it out, and it depends on how large your facilities are, it can run between $10,000 and $100,000 as a typical range. Mm-hmm. And that's why I encourage people to make sure that they have their people involved, their maintenance people and their qualified workers, to make it a training example as well as just getting the study completed.
Okay, how often how often do arc flash labels need to be updated, and why do they have to be updated if the equipment has not changed its configuration?
Good question. They don't have to be updated if it hasn't changed. They do have to be reviewed. The status has to be reviewed every 5 years of the overall assessment, or anytime there's a change that affects the calculations or the results. There are methodologies to prevent having to redo the label. And if you notice on our website, we have a generic label that has the date on it. And some people replace it or update it by putting a sticker over the date. So there's ways to kind of deal with having to remove or replace it. But the point is to give the person, and one of my favorite label accoutrements is a QR code, which the field worker could go up and scan and tell immediately how old the data is and what it needs, how it applies to his particular need for PPE.
Okay. Should we consider the worst case scenario for labels or the normal operating conditions?
It's absolutely the worst case scenarios is the most conservative approach.
Should we also mention the arc flash levels for normal operating conditions?
So an arc flash label is required on any equipment that's going to be opened up and have humans exposed while the equipment's in operations. As long as that equipment's closed up and secure, the arc flash boundary doesn't exist, nor do the electroshock boundaries. Now, the question is there an arc flash hazard there even if the door is closed? And that goes back to the assessment during data collection of whether or not the equipment is adequate to the task. And so in those cases, there may be a procedure for operating the breaker or a panel control, even though it's closed up, because the manufacturer because the equipment's old and the maintenance is doubtful. And so there may be a procedure specific to that piece of equipment because of how much energy we know is behind the panel. So that's a little bit more specific.
Okay. We are working on a project with both utility and through an ATS connection to generator backup. What is better, 2 separate labels or 1 label for with both ratings?
It depends if you're going to have maintenance under either condition or both conditions. What's ironic is that the generator supply is usually more dangerous because the currents are lower than the utility, and the lower current means a slower response time for the protective devices. So I think I'd go with 2 labels.
Okay.
If I have maintenance during both periods.
Okay, is there a current value associated with the 50-volt threshold?
Current value of what?
I don't know. The question was, is there a current value
Oh,
associated with the 50-volt
amperage.
threshold? Yes.
Amperage.
Yes.
No. The bottom line is the reaction time of the protective devices. And so a 50-volt, a low amperage arc may not last that long. And it depends on the device. It depends on the air gap. It depends on the amount of energy behind that voltage. So the answer is maybe.
Okay, should we have settings on bus coupler breakers? Does it matter if we disable them to avoid nuisance tripping?
Well, nuisance tripping is an indication or a symptom of something being seriously wrong with the coordination of the device. So unfortunately, people disable it or set the trip settings higher. And as they do that, they are actually not just endangering personnel, but they're potentially decreasing the life of the equipment because you're going to have more current than it expects to see. So my response would be check your selective coordination before you start adjusting stuff.
Okay, question. What do you think about keeping incident energy under control by calculating adequate transformer impedance at the very beginning of the project?
That's a little dicey. Again, what you're doing is you're looking for not the worst case, but you're looking for the best case in terms of PPE results. And what if you're wrong could be a disaster, only maybe less often than what you were shooting for. I guess I wouldn't encourage that. So the solution is to calculate with worst case and best case, and then make a decision on how much risk either or involves.
Okay. Christopher asks, please provide the link to the PDF manual for procedures to complete an arc flash report. Christopher, if you just write to Jim at EasyPower, he'll send you that.
It's in the
That
PDF
PDF.
too.
Yeah, and it's in there as well, the link to it as well. Okay, could we still use the old version, the 2012 calculation today, or do we have to use the new IEEE 2018?
Depends on, so the answer is yes, you can use the older version. And my recommendation would be to justify why you think you need to do that. But so that's why they refer to these as consensus standards. The only legal document is the OSHA regulations, and OSHA doesn't get into the details of how to calculate arc flash or the standard or the methodology to be used. And so as long you may have a better way of doing something versus what 1584 says, as long as you document it and are prepared to show somebody in the case of a problem that your way was better for your situation, if you're not going to use the standard that's recommended.
Okay. Could you explain the terms like arc flash boundary, working distance, limited approach boundary, restricted boundary, etc.?
Well, in fact, those are in that book, but restricted approach and limited approach are electroshock boundaries that are determined by voltage. The arc flash boundary is that point away from an arc source that the incident energy becomes 1.2 calories per square centimeter. And that varies based upon how much energy is in the arc. And then the working distance for a label, it's standardized by 1584 based upon the type of equipment and the voltage. And normally it's 18 inches for 480 volts. Mm-hmm. The one gotcha in there is the working distance for actual work, and that can be considerably less than the 18 inches.
Okay. What do you think of arc flash labels on disconnect switches? Is a label required?
I love the question. The answer is, will that disconnect ever be opened up, the container, the box ever be opened up while there's voltage and humans going to do the opening? If the answer is yes, then it needs a label. Okay.
Can you please discuss arc flash on DC systems such as batteries, inverter-based systems?
The answer is yes. 1584 does not cover arc flash model for DC. EasyPower uses a method called max power method, which has been presented in several papers in IEEE presentations. More recently, it's been discussed that the max power method is a little too conservative. And so there's been papers at several conferences I've attended that suggest there's a less conservative methodology coming out. And we should see announcements on that during this coming year. And EasyPower will basically follow that based upon the consensus.
Okay. Are you aware of arc flash events on 208, 120 volt systems?
Not on 120, on 208, yes. Mm-hmm. But they're less of a problem at low current. In fact, that's the cutoff. Below 240 volts and less, and with 2000 amps available fault current and less, they're considered a non-probable hazardous source.
All right. Can EasyPower calculate the incident energy for arc in a box that is more than 15 kV?
Yes. We don't use 1584. We use either Ralph-Lee method or something equivalent to it's described in the NESIC tables of 2009. But the answer is yes.
Okay, that's great. Okay, excellent questions, everyone, and excellent
thank you.
answers. You've got two great presentations so far today. Thanks very much, Jim. Appreciate it.
My pleasure.
I put Jim's I put Jim's email address into the chat. I also posted to the chat again the EasyPower handbook that he was referring to. If you can't download it from Zoom, then he has a link to it in his presentation. You get it from there, or you can write to Jim and ask him where you can get it. Okay, so that's great. Thanks very much, Jim. Appreciate it.